Hey guys, Grassman here. So today we're looking at a problem called the graceful tree problem. Number file did a video on it, so if you want to know more about it, just go look at that video. But I hope you can see the paper okay as well. So I'm wondering what happens if you... I want to show what happens if you try and do it with an infinite snake. So basically the problem is, I'm going to try and write it in a way you can somewhat see. So to explain it, it's circles connected by lines, or just something connected by lines, and in these circles you put the odd numbers. So in this case, I have 5 circles, so I need the first five odd numbers. So 1, 3, 5, 7, and 9. And then I have to put them somewhere in this thing. Can you see that? I know the lighting's a bit bad. So I have to put them in the circles in a way that when I subtract them, they don't. I'll write the next ones bigger as well, so you can see better. I have to put them in circles in a way that they don't subtract to equal the same same even numbers. So for this one, you put 1 at the crossroad, 9 and 7 up top, 5 below, and 3 under that. So it looks like, if you can see that. Then when you do subtraction, 7 minus 1 is 6, 9 minus 1 is 8, 5 minus 1 is 4, and 5 minus 3 is 2. So they all equal different even numbers. Can you see that? Somewhat. So now the question, and so the thing about this is that we don't know if they're actually all possible. There's never been one that's found to be impossible, but they can't prove that they're all possible either. So they don't know if there's one they've never found one that's impossible, and they can't prove they're all possible. But I do know a couple species are all possible. One species is the starfish, and it goes like this. You see that? I'm trying to hang on, I'll see if I can get a pen. Okay, back. So I found this pen, and I'm going to start writing in pen instead. So, for these ones, it's very simple. No matter what, you just put 1 in the middle, and then you're done. So you put your lowest or your highest odd number in the middle, and then you put everything else around the outside, and it always works out. So 3, 5, 7, 9, 11, 13. It'll always just equal 1 less. 2, 4, 6, 8, 10, 12. Simple. So there's another species called the snake, and the snake's always possible as well. So 1, can you see that? Those are probably too small, but this is only the example. Connect those. So here's that one example, and then here's the snake. So the snake is just one attached to another, to another, to another, to another. And the way to solve this is you put your 1, so you put your 1 in 1, you skip 1, then put 3, skip 1, put 5. So you see what I'm doing? So is it upside down? It might be. But you got 1, 3, 5. Then you come back. I put 7 here, I put 9 here. And what's doing the math? That's 8. This one is 6. This one is 4, and this one is 2. And then it creates the descending order. So 8, 6, 4, 2. So now the question is, can you do it with an infinite snake? And when I was first watching the video, I was like, okay, so can it be done infinitely? Because the thing about this is, you have to write each number and then skip a space. Meaning you then have to come back. So that means in the second space, to have written a number there is to say the snake wasn't actually infinite. So can it actually be done with an infinite snake because of the way you have to solve it? Well, let's find out. So I'm going to draw it bigger here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Connect those. Good? Can you kind of see that? You can kind of see that, right? So you can see the circles? And then we'll just say, we'll go dot, 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 dot. It continues on forever. So first off, we can simply put 1, 3, 5, 7, 9 right there, no problem. How do we come back? In between 7 and 9, putting anything would be to say the snake wasn't actually infinite. So what do we do? Well, you can kind of actually, I don't know where this circle came from. This is me testing it. So if we put a couple other circles here, connect them. So the infinite bit's all happening in this dot. I'm going to flip the paper around so you can kind of see. The infinite bit is all happening in those, like, dot area, in that dot area. So you have 9 here, and then it's infinite. And this is just, we're saying an end. We're giving an end, even though that end is technically infinitely far away. So I'll move it over here so you can kind of see it a little better. Move it off the back so you can see it even better. That works okay? So what we can do is there are numbers to signify something after an infinite series. So after this infinite series, the number we can put down is called Aleph Null. Right, so this is something I learned from Vsauce. So this isn't working super well. So the odd number should be second here. So ignoring that one doesn't exist. Here we can put Aleph Null, and the symbol for Aleph Null is an N with a little 0. It's like saying no. Can you see that? No, because of the light. So Aleph Null. It technically looks a little bit different. The N's like a special N. So that's Aleph Null. And that is the number after the infinite series. This one's just empty. You see this? So this, I know it's really hard to see, sorry. So this one's just empty, because that's the other odd one we have to come back to. So how do we know about for this one? Well, because we actually have Aleph Null here, for this one, this is just the next one. This one is just, I'm gonna run out of space here, but I can just write Aleph Null plus 2. We don't have to write a specific number, it's just 2 higher than Aleph Null. Each odd number is 2 higher. So we just say here, you see it? Aleph Null is odd, Aleph Null plus 2 is also odd, but it's just the next odd number. It doesn't matter what the final odd number is, because there is no final odd number. Aleph Null is just the next odd number. But then how do we go here? The number in between 9 and 7 can't be Aleph Null plus anything because it's infinitely long in between. So what do? We go back over here to our 1. So we get here, we write Aleph 1. Can you see that? So Aleph 1 comes after Aleph Null. So there we have Aleph 1. Here, we can't write Aleph, it's not Aleph 1 plus something, it's Aleph 1 minus 2. So we get Aleph 1 minus 2. Then we go Aleph 1 minus 4. Aleph 1 minus 6, and so on. So we've been able to come back. We were able to come back through two infinite series later. We have Aleph 1. So you can actually write the numbers down, because this isn't any specific number. This is 2 infinities later. So it can actually be done. And when you do the math to figure out, is it actually possible? So first off, all the Aleph numbers are odd, so it will still give us an even number. So, what are they called? Polynomials, I think is what we have to do here. So these ones equal, this is equal to Aleph 1 minus 1. This one here is Aleph 1 minus 3. And